Congratulations, you've made it to the final standard of quarter two, which is more similar triangles. But now the triangles are some of them are gonna be combined together, which these are not. So this is supposed to be my easy example. These two triangles are similar, so solve for x. You set up a proportion. The only way you can mess it up is if you go from one triangle to the other and you go diagonally, which means you go from left side to bottom side or bottom side to left side. So as long as you go 4 to 10 or 6 to x, you're good. And if your first fraction is in the same triangle, you're always going to be good. So since that always works, I'm just going to do it that way. 4 over 6. Now I went left to bottom, so I have to go left to bottom over here, which is 10 over x. The only way I can mess this up if I start 4 over 6 is if I go x over 10, because then I switched my order. I went left on top, bottom, and now I went bottom on top, left on the bottom. So that would be the opposite order. So it has to be this. All right, and then you cross multiply and you get 4x is equal to 60. And you divide by 4 and you get 15. So that side there is 15. Now, the way this gets a little trickier is if these, say you have your 10 and your x triangle here, but you put the little triangle inside there, so this becomes 4, 6, 6, and x. These are the exact same problems. I know they don't look like it, but this is the exact same thing as what I just did. This little triangle here is the 4, 6. This big triangle is the 10x. You just don't see the 10. You see they split the 10 into 4 and 6 sections. So you're not actually going to use this number right here in your calculations when you set up your fractions. You're going to have to use the sum of this whole side. So what I recommend you do in these problems is break these triangles apart. Redraw them like the first problem that I did. Draw this little triangle up here, and it's a 4, 6. And then you can basically like redraw the big one or just erase that line. And what is 4 plus 6? It's 10. Now you've got the same problem that you started with, and it's a lot easier. If you don't do that, you're going to end up inevitably using this 6 right here in your calculation, and that's going to mess you up. All right, because this is not correct. 4 over 6 does not equal 6 over x. If you try to do left to bottom, it's not going to work because this needs to be a 10. All right, so be careful on that. And this works with right triangles. This works with real life examples. Like the sun outside is shining, so it makes a shadow. So you've got a flagpole here. Yes, that is my beautiful flagpole. And it's making a shadow that lands like right around here. So that's where the shadow lands. And it makes the flagpole is at a 90-degree angle with the ground. All right. What we can measure, we can't measure the flagpole because it's too tall, but we can measure the length of its shadow. Let's say its shadow is 20 feet long. Now you've got, say, me standing over here, and I'm 6 feet tall. I'm not going to write the feet. 6, and my shadow is 10 feet long, we'll say. So I make a 10-foot shadow. These two triangles are similar. I'm standing at a right angle, and the angle of the shadow of the sun is the same because the sun makes the same shadow for everything that it hits. All right, so these two triangles are similar because of angle. There's one, the angle of the shadow is the same, and the right angle is the same, so these angles up here must be the same. Remember angle? All right, so because those two triangles are similar, we can now figure out the height of the flagpole because we've got 3 out of our 4 numbers done. We just have one variable. So let's go the same triangle. X over 20 is equal to, that was left to bottom, so I have to go left to bottom here, 6 over 10. So that's 10x is equal to 120. So x is equal to 12. So the flagpole was 12 feet tall. Maybe you can figure that out in your head if you notice that this triangle is twice as big as that one, because 20 is twice as big as 10, so the flagpole must be twice as tall as me. Now, where this can get tricky is just like that last one. I started off with, right here, I have two separate triangles. It's pretty easy when they're separate. But when they get mashed together, it gets a little more difficult. And the way this can get mashed together is if I'm standing right here. So if I'm standing right here, I'm still 6 feet tall. I still make a 10-foot shadow, but now I'm only standing 10 feet away from the flagpole. Right, so both those distances, I'm right in between the end of my shadow and the flagpole, even though I didn't quite draw it that way. Both those distances are 10. So what's the little triangle, which I make? It's still a 6'10" triangle. That didn't change. What's the big triangle? It's still X and 20. The flagpole is still making a 20-foot shadow, but you see, you don't see the number 20 here. So just like that last one, you can get in trouble when you set up your proportions if you're using this 10 instead of this 20. So if the triangles are mashed together, if one is inside the other, be careful on your numbers. One of these sides, you're going to have to add two numbers together if the triangles are connected together like that. So it could either be a right triangle with a real life example, or it could just be what I showed you earlier, where there's one triangle inside the other. So be careful on that.